Hello all, welcome to A Gap Logics. In the previous class, we have discussed about the blinking of LED and interfacing of serial monitor and push button in active low with pull-up resistor. In today's class, we are going to learn about push button in active high with pull-down resistor. So let us, as usual, in the previous class, how I have discussed it with you guys is first to implement the circuit connections and then write the code for that particular circuit to make it operate to our desired operation. So let me take an Arduino. Okay, I have taken the Arduino, yeah, and a breadboard. I have taken it. So let me take an push button. This is the push button I have taken. So let me take an resistor whose value is 1k or any value you take it. Yeah, now let's make in connections. So see, this is resistor is called as pull down resistor. So I have connected one end of resistor to the ground pin of the Arduino, and I have connected resistor other end to the one of the uh, terminal of the push button switch, and I have connected the other terminal of the push button switch to the 5 volts of the battery supply. So this push button can be have two internal switches. So this pin and this particular pin are connected internally when we push this particular button. Similarly, this particular pin and this particular pin will make a connection when we push this button. So I have used these two pins to make you understand about the pull down resistor push button configuration in active high with pull down resistor. So next we have to take output right from this particular terminal. So for that I have taken an output which is in the green color wide, and I have connected it to the ninth pin. So what does this what will happen if we connect like this? So the thing is, when the push button is in off state or when the push button is not pressed, then we will get the output low. Okay, output low, that is 0 0 volts or the logic 0. So that is why this particular resistor is called as pull down resistor, because when we don't press the button push button, so we are getting the 0 volts. It means we are getting the low voltage. It means we are getting the low voltage, right? So for that reason we will call this particular resistor as pull down resistor. And also when we press this particular push button, okay, when we press this particular push button, we will get the 5 volts as output or the one logical one. So for that reason this configuration is called as active high configuration. Okay, why does this configuration is called as pull down, why does this configuration is called as active high? Means when we press the push button we will get the output of 5 volts to the Arduino via pin number 9. For that reason, particular reason, we will call this particular configuration as active high. Whenever the push button is active or whenever the push button is pressed or whenever the push button is on, then at that point of time we are getting the high voltage. For that reason, we call this configuration as active high. Okay, yeah. So similarly, why does this particular resistor is called as pull down resistor? Means whenever the push button is in the off state or the whenever the push button is not pressed, or whenever the push button is in the ideal mode, okay, then we are getting the output of 0 volts. it means that this particular resistor is pulling down the voltage to 0 volts. For that particular reason we call this particular resistor as a pull down resistor. Okay, yeah, I hope you got this particular point. So this is the connections, this is all about the connections. So let me explain you code. Okay, yeah, let me explain you code. Yeah, let me discuss the code with you. So first we have to take a variable to take the input via this particular green line to the pin number 9. The input is getting from the push button, right? Based on the push button state, or that is when we whether we pressed or whether we not pressed the push button, based upon this we are getting the input from this particular connection from the push button. For that we have to take an input that is given to the pin number 9. For that we have to declare an variable. So that I am declaring a variable. So you can see over here I have declared the push button equal to 9, and I have assigned 9 because I have connected it to the ninth pin, right? So that I have assigned this particular push button variable to the 9. So next what we have to do is we have to take, while reading in the previous class also I have discussed, while reading or while we are getting while we are getting any inputs from the external to the Arduino, we have to take an additional variable along with the pin declaration. Okay, to know whether which state it is. Okay, to know which state it is, whether it may be high or low. For that reason we have to take in another variable also. So I have taken this button state along with the push button. Okay, so the push button is telling that the push button input is coming to the ninth pin of the Arduino, whereas this button state tells what type of information is coming, whether it may be the high or low. This particular thing will be stored in the button state. So when we write an digital output, or when we send output from Arduino to external world, we will know that particular value, right? Whether we are going to send low or high. So we will know that particular value. So we don't need any extra variable while sending output from the Arduino to the outside world, or while writing the output to the while writing the data to the out from the Arduino. While reading from the external world to the Arduino into the Arduino, so we don't know what type of information is coming, whether it may be the high or low. For that particular reason we have to declare an additional variable. For that particular reason we have to declare an additional variable along with the pin. Okay, along with the pin that we are going to use. In this case I am going to use the ninth pin, and for that thing I have declared push button. So to determine whether it is high or low, to know what is this high or low, I have declared another variable, that is button state. Based upon this, we will write some conditions for high based upon this button state, using the if else loop or some other case statements or any statements. We will write some cases or the conditions. Okay, if this button state is high, you do this particular operation. If the button state is low, you do this particular this type of operation. So actually we don't know, right? So actually we don't know what type of output is what type of input is getting to the Arduino from the external world, whether it may be the high or low. So that we will write for the both the conditions, for the high and low as well, using the if else conditions and switch case conditions. So that we need this particular button state variable. So I hope you guys know about this. So the next thing is we have to declare we have to uh, tell to the program whether the ninth pin is acting as an input or output. Here we are getting the input from the push button. Okay, circuitry uh, push button circuitry to the Arduino. So that we will declare ninth pin as input. For that I am going to use pin mode push button comma input. Okay, next I have declared the serial monitor to display the outputs accordingly based on this button state, which is the information getting from the push button externally. Okay, yeah, I have declared the serial monitor serial.begin 9600 baud rate. So the next thing is, uh, in the while loop I have written this button state equal to digital read of push button. Okay, if you simply write this, then we don't know whether uh, it is high or low. Okay, it must be stored in a variable. For that reason I have declared button state. Okay, now this particular digital read push button, it may be high or low for some point of time, right? So at that point of time, whenever it is high or low, it will automatically stored in another variable which is button state. Okay, so we simply call this particular button state whenever we require the push button input to the Arduino. So based on this button state, we will write some conditions to the both high and low cases. Okay, so let me show this as well. If button state equal to high, whenever this particular button state is equal to high, that is, what does this button state indicates? It's the input that is getting to the Arduino from the push button itself, right? So based off, if the button state equal to high means, if the push button if the input to the Arduino from the push button is high, input to the Arduino from the push button is high, then what should happen is serial.print push button is pressed and a value is equal to, it should print this particular message which is push button is pressed, right? Whenever it is high, then it should tell, right, push button is pressed and value is equal to, what value will be, it will equal to the button state itself, right? So we need to print that particular value as well. So I have used serial.println button state. Okay, yeah, so here I have used both print and println. Print means the cursor will be, after printing this particular message push button is pressed and value is equal to, the cursor will be in that line, in the same line only, it point out to the same line only. Okay, whereas if you use serial.println, then the cursor, the message will be printed in the one line and the cursor will be pointed towards the next line after printing the particular data. Okay, so I have written the if loop, if condition, and now let us write the else condition, which is button state equal to low, right? So yeah, which is the opposite operation to this particular thing. So push button is not pressed and value is equal to, again it will be equal to the button state itself, right? So we have to print that particular variable. Here the button state is variable, so that I haven't used any double quotation marks, whereas this particular thing push button is pressed and value is equal to is a message, whereas this is the here push button is not pressed and value is equal to is as well the message. Okay, so I have written the else as well, so you may get a doubt. So whenever the button state equal to high, how do you know push button is pressed? So we already know this, because actually I have explained the theoretical concept, right? Active high with pull down resistor. So what does this means, it will be high whenever the push button is pressed as per our theoretical, right? So we are going to see it practically. So we already knew it, right? So that have written this particular message. Okay, that is push button is pressed. Okay, in the previous case, whenever it is high, I have written here, in the previous video I have written here push button is not pressed. Okay, why? Because in the active low with pull up resistor, whenever the uh, push whenever it is high, the push button is not pressed. Okay, that is already we have known, uh, we know, right, in the theoretical. So that have we have written the message accordingly. Okay, so but the thing you have to see is this particular thing. I have this particular line. Okay, if the button state is high, high, when whether you are when you are pressing or when you are not pressing the push button, you have to see that particular thing. You don't worry about this particular message. Okay, you guys don't worry about this particular message. What you need to see is you have to see this particular thing. When does the button state is high, whether it is high when pressing the push button or not pressing it. Okay, you have to see that particular thing. Okay, you have to observe that particular thing. So I have written conditions for the both high and low as well. So I'm going to specify some delay, which is 1 millisecond. Okay, so the delay will be by default in millisecond units. So I have written it this as well. So our code is completed. So let us see an output. So according to our operation, let's uh, new what will happen. Okay, so according to our operation we have discussed in theoretical. So what our expected output is, so by by default it should be low. It means it should be print whenever the push button is not pressed. It should be print, right? Print like push button is not pressed and value is equal to 0, right? 0. Okay, so why? Because it's low, right? Else means low, right? So let me do this. So I haven't pressed any push button, right? I have not pressed any push button. You can see over here. So it is showing the output, right? Push button is not pressed and value is equal to 0. This is our expected output, right? We are getting, yeah, this is our expected output for the active high with pull down resistor. Whereas in the case of active low with pull up resistor, the we will expect push button is not pressed and value is equal to 1. Okay, in that case we are going to expect the value as 1, but in this case we are going to expect the value as 0. Okay, so that's the difference between the both active high with pull down resistor and active low with pull up resistor. Okay, so let's see. So I'm going to zoom this particular thing. So see, I moved my cursor over here and pressed and and hold it. I have pressed the push button and hold it. You can see the output push button is pressed and value is equal to 1. Okay, whenever I am going to press or whenever the push button is active, whenever the push button is uh, contacted with the two terminals internally, okay, we are getting the output as equal to 1, which is in 1 in the binary. Okay, it is equal to the 5 volts. Okay, yeah, so that so that's why it is called as active high configuration. So now I have removing my finger from the mouse pad. So you can see over here you are getting the push button is not pressed and value is equal to 0. It means I'm not pressing any push button. Okay, over here I'm not pressing it. Again we are going to get the value equal to 0. It means we are getting low value, right, when it is in the ideal state or off state, when the terminals internally are not connected. So that reason we are getting the low, right? Low means this particular resistor will be called as pull down resistor because it is getting the output is getting pulled down. Pull down means to the low value, that is 0. This particular resistor is used to help to pull down the output to 0. For that particular reason, we call this particular resistor as pull down resistor. So I hope you guys got this point. So uh, the configurations of push button act to high with pull down resistor and act to low with pull up resistor is so confusing. But whenever you understand the theory completely, and like this I have shown you, right? Like this, whenever you practice by your own in the simulators or the hardware, if you have hardware with you, then you will get in clarity. So I recommend you guys to not only blindly watching this particular video, you guys practice by your own, then you can able to understand what is what. Okay, then you will get an hands-on experience about this particular uh, small things, and you will get an clarity in your mind. So this is all about this video. I hope you guys like this particular video, and if you like this video, please like, share and subscribe. Thank you.